Right, welcome back to the parent effect. Today we are looking at implicit differentiation. So in order to start with that, we need to talk about what explicit and implicit mean. So normally you've been dealing with differentiation of explicit functions, which means that y is the subject. So you're given an equation and you've got y the subject, and you differentiate the left-hand side and you get dy by dx, and you differentiate the right side and you'd get 3. And everything was happy and jolly. For implicit, you need to think about what equations would actually have x and y together on the same side, and that sometimes it might not be helpful to make y the subject because it makes the thing way too complicated. A classic example of this is obviously the circle equations. So they've got x and y on the same side. It's squared. So if you are going to make y the subject, you have to consider plus and negative square root, and things get quite complicated. So there is a technique to be able to differentiate with x's and y's. And the way in which we do that, if we just consider just the y from this one, when we differentiate it, you're going to do exactly what you do with x, so multiply by the power, take 1 off the power. But then you just need to make sure that you're explaining that you're differentiating y with respect to x. Okay, so I always say that we're showing respect to y. So we're just going to go through a couple of examples to show how it works out. So another circle equation there. If we differentiate x squared, you're just going to get 2x. If you differentiate y squared, you're going to get 2y, but then you're going to respect it. Classic mistake on the right-hand side is to just leave it as 25. It is a number, so its gradient is nothing. So just make sure that you differentiate both sides. And now you can make dy by dx a subject. Dy by dx will equal negative 2x over 2y, or we could say negative x over y. So if we wanted to know the gradient of that function at any point, we would need to know both the x and y values in order to do so. The next one, just same sort of thing, but throwing in an ln. So the derivative of x is 1. The derivative of ln y is 1 over y, but we need to show respect. And the right-hand side again becomes 0. And again, we can make dy by dx a subject by moving the 1 over and then timesing the y up. So not too difficult, those examples. The next one is more of a exam style question. So in Cambridge, I would say 9 times out of 10, you're going to get a product rule when it's an implicit. And you need to recognize that it's a product rule. So when we differentiate it, we're going to follow all the same processes, but we need to make sure that that 3xy gets split into its product rule. So just reminding you, we're going to do uv dash plus vu dash. And in this case, u is equal to 3x and y is equal to y. V is equal to y. Right, let's have a go. So x squared is going to become 2x. 3xy, we're going to do u times v dash. So the derivative of y is going to be 1 times dy by dx plus v, which is y, times u dash, which is just 3. Then y squared is going to differentiate to be 2y times dy by dx. And then moving on to the other side, x will become 1 and 3y is just going to become 3 times dy by dx. Now again, we're going to try and make dy by dx a subject, so we're going to move everything with dy by dx onto the left-hand side. And everything that doesn't have dy by dx onto the right-hand side. The 1's already there. Bring over the 2x and the 3y. And then at this point, you can differentiate it out. Okay, and then divide. And then if we want to find the gradient at the point, we're just going to put that point in. Working that out. We're going to be just substituting into the equation and getting 1 minus 4 plus 3 all over 6 minus 2 minus 3. So you'll see that on the top you actually get 0. So the gradient for this curve is actually 0 at that point. Hopefully that all makes sense. You can then have a go at the exercise, which is down below. So if you're following this on the YouTube channel, you're more than welcome to just pause, have a go at those questions. And then the answers, again, you can pause and just scrolling through to the last ones. Right, hopefully that helped you with implicit differentiation. Don't forget to like and subscribe.